in this episode how to do synthetic division for polynomials. Coming up, back into action. Hey guys, we will be doing synthetic division. Well, what is synthetic division? Synthetic division is a kind of shortcut when we divide one polynomial by another polynomial. So it's basically applied when you divide one polynomial by a special polynomial, by a polynomial in the form of x minus a or x plus a. So it's basically a linear polynomial or linear expression. And you could also apply a normal lone division, and I have another video, you can check it out later. But today we're talking about a synthetic division, which is again a shortcut. So it helps you to divide them instantly, right off the bat, and it saves you time. Alright, the gist is you are going to draw a little corner like this, and you are going to read off the coefficient of the first polynomial. For the first one, you have invisible implied 1. You are going to bring it down. For the first term, which is negative 5x, you would get negative 5, and the last is just 2. Now, on here you are going to place not negative 3, you are going to place the opposite number. So you are going to place 3 always. So whatever makes your bottom, your denominator equal to 0, so you're gonna to place kind of outside of your this little corner kind of number that's gonna be stick out. So again, if it were a positive number, let's say if we had 3, you would place negative 3. So in our case, it's negative 3. We are going to place the opposite version, which is 3. Now, this is your setup. And the next step is you're going to bring down this one. Just bring it down as is in the next line, and here you are going to leave just one line space, one row space. Now the next step, you are going to take this 3 and you're going to multiply 3 times 1, that gives you 3. You are going to place it here. So 3 times 1, and you are going to place this number over here. I'm going to draw a line, and the next step I'm going to add these two numbers. You're going to add them vertically. So minus 5 plus 3, that gives you negative 2. Now, from that point, I'm going to repeat the process. I'm taking the 3 and I'm going to multiply it by this 2, so it becomes negative 6, and I'm going to place it over there. Alright, now I'm going to add these two numbers vertically. So 2 minus 6 gives me negative 4. We are done since there are no numbers left. If you had more numbers, more coefficient, you just do the same steps. We are done at this point. Now I'm going to write my answer. So the last number actually that gives you the remainder of your division, and these two numbers that gives you coefficient of your polynomial, of your quotient basically. So this number gives you the coefficient of x, which has a power 1 less than the original power. So since you have a quadratic, you have a power of 2, the highest power that it shows up in your polynomial. So the first coefficient would be the coefficient of x that has a power 1 less. So it's power of 1. So it's x. So the next term is actually x to the 0 power. It's a constant. And this is your remainder. So typically we would write answer as so your dividend, your divisor, your quotient, and you place your remainder on top, over divisor. So this is your answer for that division problem. So generally your dividend polynomial over divisor is equal to quotient. So this is your quotient plus remainder. This is your remainder on top over divisor. This is your divisor. This is like a general formula if you like, and this is your answer for that division problem. Alright, moving on. One more. Quadratic by x plus 1. So we always start by writing out the coefficient of your dividend, which are so 1, 2, negative 6. We draw this corner, and I'm going to place there not 1 but negative 1. So whatever that makes your bottom, your denominator, equal to 0. I'm going to bring down this one, just drop it down, and I'm going to multiply this negative 1 by 1, and I'm going to place it over here, negative 1. Draw a line. Alright, so we're going to add these numbers vertically. So 2 minus 1 gives you just 1. And we're going to repeat the process. So it's like minus 1 times 1 gives you negative 1 again. So you're going to place it here. you are going to add them vertically. Minus 6 minus 1 gives you negative 7. We're done. We completed off the process. Now, the last number. This is your remainder. And I'm going to write off my quotient. This is your quotient. So becomes 1 and 1, so x. So the power of your polynomial quotient would be 1 less than the original one. So since the highest power is 2, we would start with the first power. So the coefficient is 1, yeah, so just x plus the constant is basically 1. So this is your quotient. And we could write out the final answer. So it's quotient, which is x plus 1 plus, so we're going to place remainder, which is negative 7, over your divisor, which is x plus 1 in this case. And this is your final answer for that division problem. Alright, the last one, and of course it's a special one, my special offer, my special hot meal. Suppose you are given something like this. Alright, look at the top polynomial, the dividend. What pops up? Pops up that we have x cubed, but there is no x squared term. So we have x cubed minus 3x plus 4. So actually x squared term missing. So it basically just means that you are given that the coefficient of x squared is just 0. That's important. Now we're going to start our division, synthetic division, by drawing this angle, and I'm going to place outside, I'm going to stick this negative 3. So again, it's the opposite number, the inverse version of what you have on your bottom. Now I'm going to read off the coefficient of my dividend of that top polynomial. So for the first one we have 1. Since x squared term missing, so basically the coefficient is 0, and that's important. So we have to write 0. Negative 3 and 4. So just pay attention if something is missing in your top polynomial, in your dividend, so make sure that you write zeros instead. It could be more than one term basically missing, so just make sure that you do not miss this missing term. Don't miss this missing term. Otherwise you could go astray, go wrong. So this is our setup, and as we did before, the same step we're going to repeat. I'm going to just bring down this one, so leaving one space above, one row above. We're going to multiply this negative 3 by 1, and I'm going to place this number over there. It becomes negative 3, and I'm going to add them vertically this way. 0 plus negative 3 gives you negative 3. I'm going to write it here, and from that point I'm going to repeat the process. Minus 3 times minus 3 gives me 9, positive 9. I'm placing it there, and I made them vertically. Minus 3 plus 9 gives me just positive 6. Again, one more step. Minus 3 times 6 gives me negative 18. I'm placing it there. And I add them vertically, up and down. So 4 minus 18, it's gonna be negative 14, which is my remainder. We're done with the synthetic process. This is my remainder. Now I'm going to write off my quotient. So this coefficient, this number, the first number, gives me the coefficient of x term, which has power 1 less than the original one. So the original polynomial, the dividend, the highest power is 3. So this one is the coefficient of x squared, 1 less, knock down 1. Next one, 3x and plus 6. So this is your quotient. So you can just ignore this one. You don't have to write this coefficient one. So this is the quotient. Now I'm going to write out my answer. So it becomes my quotient so this remainder goes on top, and my divisor is x plus 3. One little remark, you could actually pull out this negative out front, it's okay. Even in the previous example, you could just pull it out there, but this way it's okay. So you could basically write it like minus here and just 14 there. It's precisely the same thing. So this is your quotient, a remainder on top and divisor on bottom. And this is basically my answer for that division problem. And one pro tip, guys, of course, you could always check your answer. You could basically get the common denominator, and just to make sure that you're correct, you could get the common denominator and like kind of add these two results, and you would get the original. I hope it helps you, and train your brain, and thank you for watching. I know everyone hates maths, but if you like my video, just hit like, share with your friends, leave the comment down below and subscribe so you will not miss out my new videos.